This is the ROS Developers Podcast, episode 67.
The ROS Developers Podcast, the ROS Developers. The ROS Developers Podcast, the ROS Developers.
Hello, ROS developers, and welcome to the ROS Developers Podcast, the podcast that give you insights from the experts about how to program your robots with ROS. This is Ricardo Tellez here from The Construct, and today I would like to dedicate the episode to all those ROS developers that are considering moving into ROS2. I know that you are very comfortable with ROS1 because, we already know how it works, and we have a big base of code created to support our future developments. And ROS2 is a little bit more scary. We need to start almost from scratch and construct all the ecosystem for our robot or product once again. I know all that, okay? But after all, aren't we engineers? Aren't we here to take technological challenges and beat them? Yes, we are. So now it is a very good moment to accept the challenge and start with ROS2. And for those of you that take this step forward, this episode is dedicated to you. Today, we are going to talk with one of the persons behind the Fast-RTPS protocol development. The default DDS mechanisms that Open Robotics ships with ROS2. What is Fast-RTPS? Why it is shipped by default on ROS2? How can we take the most of it? Well, those are the questions that we are going to have answered today. But before going into that, let me remind you about our ROS Online Academy. The Construct, we have created an online academy that is called the Robot Ignite Academy, which contains ROS learning paths for beginners. So we start in this path by teaching you about Linux and Python for robotics, and then we continue teaching you all the basic ROS concepts required to become a master of ROS, a real ROS developer. We conclude in this path with a course that teaches you how to build your own robot, your own real robot, and how to ROSify it. That's it, but to add the ROS controllers to that robot. So you can practice constructing your own robot also. And I will put a link to this academy in case that you are interested in learning about ROS and ROS2 and many other topics. So you can see on the show notes the link to the academy. And now it's time that we start with the interview today. So here it is my pleasure to introduce you Jaime Martin Losa. Jaime is the CEO and founder of Eproxima, the company developing Fast-RTPS, and also the company that is developing Micro-ROS. You know that Micro-ROS is a system for putting ROS into microcontrollers. If you don't know about that, we did an interview to another of the engineers of Eproxima about the Micro-ROS a couple of weeks ago. Check our podcast list. So also Jaime is an expert in middleware, and as such he leads also the Eproxima OMG membership, and he is the responsible of Eproxima contribution to the DDS standards. So welcome to the podcast, Jaime.
Hello, Ricardo. Thank you very much for inviting me, and by the way, Happy New Year.
Happy New Year.
I have here also Catherine Kellner, that is our responsible of marketing, and she will help also answering some questions.
Hello, Ricardo. Thank you for having us.
Okay, my pleasure, Catherine, also to have you there. So we have here, this is a podcast with three people now. So myself, and then from Eproxima, Jaime and Catherine. there. Nice to have two people here on the podcast. So then the first question that I would like to ask you is for the people that are listening. Is what is RTPS? Because the DDS mechanism implemented in the ROS2 is called Fast-RTPS. So what is the meaning of this RTPS?
Very good question, Ricardo. Very good question. Well, as you know, and all your attendees know, ROS2 uses DDS, the Data Distribution Service Standard, and it's an underlying communication middleware. And RTPS is the real-time publish subscribe protocol.
Okay, real-time publish subscribe protocol. Okay, what is that?
Well, this protocol is the protocol behind DDS.
Okay.
So basically, if ROS2 is using DDS, DDS is using RTPS. DDS, you can consider DDS as the API and RTPS as the protocol.
Okay. Then so then I see. So ROS2 uses DDS, and then DDS uses RTPS. Okay, and then
RTPS is part of the standard of the DDS standard. So in the DDS standard, you have both the protocol and a set of APIs and services on top of the protocol. So at the very beginning, we started with a minimal implementation of RTPS, and that is why we call it Fast-RTPS.
Okay, so that Fast-RTPS is your own implementation of this RTPS protocol.
Exactly. Because once upon a time, because that was 5 years ago, we started with a very minimal implementation of the RTPS protocol. That is why we call it Fast-RTPS. But over the years, the child has grown a lot and implemented on top of the protocol a lot of the different APIs and services defined by the DDS specification. So right now, Fast-RTPS is a DDS implementation, and as a matter of fact, we are planning to change the name very soon, and Fast-RTPS is going to become Fast-DTS.
Okay. So I think that this is ROS news, isn't it? So nobody else knows.
Exactly. This is a big announcement, and we plan for Foxy, that is the next release of ROS2, to be able to change the name, because we are implementing the modern C++ DDS API, that is a new specification of the ONG. And using that fact, we are going to change the name to Fast-DTS.
Okay. And then you also mentioned that Fast-RTPS is shipped by default with ROS2. So what does it mean? Because the audience, there is people that is very well versed in ROS2, but there are a lot of people also that are just starting with ROS2, and maybe this thing about the DDS and the default DDS on ROS2, they don't understand very well. So what does it mean that Fast-RTPS is shipped by default with ROS2?
Well, basically you have to understand that our company, we have here 20 engineers that are working only on ROS2. So our focus is ROS2. We have several projects, including Fast-RTPS, but not only Fast-RTPS, but other projects. We will talk maybe later about that. And our roadmap is totally driven by the ROS2 community. So what it means is that Fast-RTPS is the most complete DDS implementation for ROS2. And we meet all the requirements of the ROS community in terms of features and performance. So that is why we are the default implementation. Our team is totally focused in ROS. It's not just Fast-RTPS, but micro-ROS, the secure ROS, the secure version of ROS, and the ROS integration service, that is a new upcoming module of ROS2 that allows you to connect ROS2 to different protocols. So, for example, MQTT or StereoMQ, a file, a database, whatever. So, as I said, we started 5 years ago, and right now we have more than 20,000 clones per month of our repo.
Wow.
And really a lot of users. So, because of this, Fast-RTPS is tested in many different use cases and is used in production in many real-time and critical applications in robotics and other sectors such as air traffic control, autonomous driving, UAVs, a lot of different things. And that is why we are trusted by the community, and we are the default implementation of ROS2.
Okay. So then for the listeners that doesn't know very much about ROS2, so DDS is the transport mechanism of messages in ROS, in between ROS nodes. And then the default one that comes with ROS2 is called Fast-RTPS, the one that Proxima, Jaime and his team, they are developing. But then can we use other DDS implementations in ROS2? I mean, how did it happen that your DDS implementation was selected as the default one for ROS2?
Well, at the very beginning, ROS2 used a different DDS implementation. They were using the AD-Link Open Splice DDS as the default implementation. And they support also the LTI Connects DDS implementation, for example. But these companies have their own interests and goals, and basically the core business is not ROS. So, for example, AD-Link, the main business is building hardware, and they have just arrived to the ROS ecosystem. So that is why, because we are very focused on our ROS and we have a very good relationship with the community, they changed in the past the default implementation to Fast-RTPS. I think also, well, the size of the team we have working on this just for the ROS community is a key differentiator.
Yeah, I think it's safe to say that other companies with their key focus on other elements only have a few engineers working on their implementations.
Okay, so I understand. And it means that if you are a user of ROS2, you can change, if you want, the default DDS implementation by another one that is provided by other companies. But the thing here is that the other companies that are also creating other DDS implementations, they have actually their time and their team for dedicating to develop that is not is not their main core business. And then in your case, in Proxima, the development of Fast-RTPS is a core goal, is a core activity of your company, isn't it? And then you have so many engineers, a team. How many engineers you mentioned you have?
20 engineers.
20 engineers.
For example, other implementations such as Cyclone, they have basically 2 engineers working on that. But it's not only that the number of engineers, but the focus on ROS. Because for us, the ROS community is our mindset. Many of our important customers are there, and we have customers in other sectors, but the ROS community is a good place to drive the adoption of Fast-RTPS. And our efforts and also our marketing efforts are to spread Fast-RTPS within the ROS community and create every release of ROS2 and even better Fast-RTPS for ROS.
Okay. Very good. And then you recently presented the latest version of Fast-RTPS that now is shipping with ROS2 Eloquent, the last version also, the last distribution of ROS2. So you presented these on the ROS Industrial Workshop in December. So now we are in January, and you presented this in December. And can you tell us about the new features that you have introduced in this version of Fast-RTPS that is shipped with ROS2 Eloquent?
Sure. Well, basically, this new version features real-time behavior and a lot of performance improvements. And what is the meaning of real-time behavior? Real-time behavior means determinism. It is not only that your application is going to be fast, but it's going to expose always the same performance. So, for example, imagine you have a robot and you want to stop it if there is an obstacle, and then your middleware gives you a median latency of around 100 microseconds, but sometimes the latency increases up to 500 microseconds. Because the middleware is doing some internal operations in the meanwhile, such as allocating some more memory. That would be a really big problem, and well, for real-time applications, you need really determinism. And in this case, Apex.ai, that is a big player in the ROS community, and they do autonomous driving systems, funded us to create a new version of Fast-RTPS suitable for real-time systems. So we modified Fast-RTPS to create a version with no dynamic memory allocations or no blocking calls and unstriking performance. So as a result, Fast-RTPS is the only open source DDS implementation with this creative feature.
Wow.
It's not only some specialized commercial implementations out there. So, for example, RTI Micro and others that are very expensive include this feature. But in the open source ecosystem, just Fast-RTPS includes this.
Wow. Impressive.
So, we did a lot of improvements in terms of performance, and we released recently a set of performance tests, and we benchmarked this latest version of Fast-RTPS versus the main open source alternatives. And, well, as you can guess, we beat the competition by far in terms of latency and throughput, even if it is, for some of them, their motto, this thing of faster, smaller, and easier. Well, that is not true. We are faster, a lot faster, and in very different scenarios, in intra-process, in inter-process, in different machines. And you can check this in our results in our website, but also you can check it by yourself, because all the code is available for this benchmarking suite. And we created a project to reproduce the results.
Okay.
So,
great.
Well, this new release of Fast-RTPS is not only the most complete open source DDS implementation for ROS2, including many premium features not included in our competitors. For example, the DDS security, micro support, dynamic types, the real-time behavior, the integration service, the server-based discovery, extended QoS support, and a lot of features. But also, we are faster than the competition. But this is very difficult, because when you have more and more features, you have to pay a price, usually, in performance. But in our case, for many cases, we are faster than the competition.
Oh, okay. Very good. Impressive. This new version is the version 1.9.
Exactly.
Okay. Is the one that you have included all these new improvements, and also not only improvements but also new features.
Exactly. So 1.9.x, we are now in 1.9.3, but next week we are going to release 1.9.4 with some minor improvements. Well, also, I should say here that we have here for this release hundreds of success cases, public success cases, and this means that Fast-RTPS is fully tested. You can rely really on this implementation for production.
Okay, and then what I'm going to do is to put a link to on the show notes to your repo containing this new version, and also any other documentation that you may have, because you have mentioned a lot of features like the DDS security, micro ROS support, dynamic types, real-time behavior, and so on, that we cannot discuss all of them here in this podcast in detail. So do you have any place where the audience can go and check documentation about how all this works? So it's already documented, all those features.
Yes, we have a very comprehensive data docs that is also a key differentiator of Fast-RTPS, that we have a very good documentation.
Okay.
And also we publish everything, even our designs, internal designs for the features. Everything is in GitHub, and you can check the design of every feature. And you can also include this link to our project to testing the performance.
Correct.
So the benchmarking repo we have. Fast-RTPS.
Okay, so I will do that. So I will put the link to the code, to the repo of the 1.9, also to the read the docs place where you are providing the documentation for all this new version, and also the link to the ROS jack that allows anybody to reproduce the benchmarks results and check by themselves that the results that you are indicating here about the speed and performance so good, they can check by themselves. They can reproduce the everything, and inside this ROS jack, everything is already prepared. It contains some documentation there, because I have checked your ROS jack, this one that you mentioned. So I know that you have put some documentation about the steps about how to reproduce, but everything is already prepared and with all the code already there, so just to execute and get the results. Okay.
Exactly.
Okay, so I will put all that audience, people, ROS developers that are there listening. So I will put all this on the show notes. Please be sure to check.
Probably very soon this is going to be automated. We have a project to automate all our benchmarking tests. Right now, every pull request we do to our repo, in our continuous integration system, you have to pass all the tests, including the performance tests. And we have a team here at the Proxima just focused on performance.
Okay, yeah. So that means that if you do some changes, then not only you are checking for unit test and other functionalities, but also about performance. So if the performance has decreased, then you are going to reject the
request. We allow a small delta of a small difference between the performance between the current version and a pull request version. If there is such a difference, the build files.
Okay, so another question. So can you explain us about what are the two different modes of operations of ROS2 and how Fast-RTPS works in both modes?
Okay, I think you are talking here about synchronous versus asynchronous publishing, right?
Yeah, exactly.
Okay, well, this is very hard to explain. Let me try. You can set up ROS2 to publish synchronously, and in that case, the user thread is going to publish the data, or asynchronously. And in that case, the user thread copies the data to a middleware buffer, and it is the middleware thread the one really doing the publication.
Okay.
So, with that in mind, the faster option in terms of round trip latency is the synchronous one. That means when you need speed, you should use synchronously mode.
Okay, synchronous mode.
Synchronous mode, exactly. But in many real-time applications, they prefer the user thread to return immediately, that is asynchronously, to ensure a deterministic behavior. So, for example, this is more important when you have big data and you need to fragment your data. In the case of UDP, that is when you have data bigger than 64 kilobytes. Okay, so in that case, synchronous publication could lead to a long blocking time because the user thread should perform all the fragmenting and the processing of sending the fragments. And in that case, it's more convenient to use asynchronous publishing.
Okay. And then Fast-RTPS can work in both modes.
Exactly. And the RMW of Fast-RTPS supports both modes of operation. By default, right now, is set up to use asynchronous publishing because we have many users out there using ROS2 in real-time scenarios. So, for example, the Apex framework for autonomous driving. But as right now we have many users testing the performance of ROS2. We are switching the default in this very next release that we are releasing next week to synchronously.
Okay. So you are going to switch back. So you are going to put the default mode of operation of Fast-RTPS in ROS2 is going to be synchronous. But
exactly.
Only from the next version that you are going to publish in the next week.
You're right.
Yeah. Okay.
Right now it's async.
Right now it's asynchronous.
Exactly.
As right now, I mean for the listeners, is right now is in the first week of January of 2020. Okay.
Yes, but very soon, for next week, we are releasing a new minor version of Fast-RTPS, and one of the changes is going to be changing that default to synchronous publishing.
Okay, and can you tell us more about the discovery server? You know, what is the reason to be of this discovery server, and what is the advantage respect to other DDS implementations that doesn't have this discovery server?
Well, the DDS standard and discovery uses a mechanism in which all the nodes should announce themselves using multicast, and later they talk to each other to complete the discovery.
Okay. That's in. Sorry, this is in order to, because in ROS2 we don't have this ROS core, and then so in order to all the nodes to know about the other nodes, and then they need to do this multicast.
Exactly. Well, this is kind of magic, right?
Yeah.
Because everything is happening automatically, and you don't know how. Well, basically, what is happening behind the scenes is that every node is sending a multicast announcement and announcing its presence, and afterwards, each node should talk to each other. That means that you have a number of conversations proportional to the square of the number of nodes, and that could be really a lot. So, for example, if you have 100 nodes, that means 10,000 conversations.
Yes.
So, in that situation, when you have, let's say, more than 1,000 nodes, and we have cases for that, you should consider to use the server-based discovery.
Okay.
In that scenario, this is something similar to the ROS1 master of the ROS core. All the nodes just talk to the discovery server for the discovery phase. They register themselves in the discovery server and they ask what is out there for me. And in this case, the number of conversations is proportional to the number of nodes. So very scalable.
Okay.
So again, this feature, by the way, is just available on Fast-RTPS. This is a super premium feature. There are this is only available in some very expensive commercial implementations, but it is not available on any other open source DDS implementation.
Okay, it's amazing that, and then that simplifies in the case that we have so many nodes, like in the like we are going to have in the complex robots that we need. So in the robots that we are trying to build to serve us, to be useful for us, not just research things, but for real stuff, we are going to need to have a lot of nodes there. But then, one question for me is that then that is kind of bringing us back to the ROS core single point of failure that we had in ROS1. Is it right, or is there something there that I'm not grasping?
Well, yes and no.
Okay.
And no, because the discovery server allows you to set up many redundant discovery servers.
Okay. A good point. I see. Okay. Yes, in case that one fails, there is another one, and so on. Okay. Great. Okay.
And it's not. I have to add also. It's not only for one single robot. You can consider fleets of robots. The discovery server is aimed when you have a lot of different robots cooperating. So, for example, in the case of fleets of robots or swarms of robots, then you have a distributed system when you have sensors out there in for example, in a building, and the sensors are integrated as part of your robotic system. Yeah. So, in that case, you can think about a system of systems, or
I see. So a fleet of robots, or even IoT devices, I would say. So it's like IoT devices that all of them, they can see each other and talk to each other and request. And then that the number of nodes, could be thousands. Yeah, it can be thousands. Okay. Great. Then, what about using ROS2 in distributed machines? I mean, is there any difference between using Fast-RTPS and other DDS implementations? When I mean by ROS2 in distributed machines, I mean that not all the nodes are executed inside the same computer, but we have a bunch of computers, like the case that you mentioned right now about fleets of robots. So what is is there any difference between using Fast-RTPS or any other DDS implementation?
Well, very good question, because I think that is the scenario for ROS2 and for a middleware. When you have different machines, different operating systems, different hardware, in that case, we beat the competition by far, and we are striking fast. Published a benchmarking study, this one of the ROS2, comparing us with the most important open source DDS implementation in this scenario. And you can try it by yourself, just comparing the code or using the ROS2. Because many studies that are published out there, they use same application, same process to benchmark ROS2 or different middleware alternatives. And actually, when you have this kind of a scenario, you have a single application, you don't need a middleware, usually. Because if you want to share some data between different threads of your application or different modules, you can use variables, you can use keywords, whatever. But you don't use such a complex system as ROS2 for a single application. It is when you have a distributed system with different applications, different nodes, different operating systems. In that case, you use a middle one. And in that case, we are really, really fast.
Okay, it's like it was in your design of the Fast-RTPS, so you had this condition about working on distributed machines as a main condition for developing Fast-RTPS.
Well, exactly. Basically, DDS was designed for this.
Okay, the protocol, the DDS itself, it's then the implementation may take advantage of that or not, or so may decide to implement this or not. In your case, you have.
No, well, any implementation should implement the full RTPS protocol, but what I say that DDS was not thought as an intra-process mechanism, but it is thought for distributed systems. DDS stands for Data Distribution Service, and it's for real-time distributed systems.
Okay, I got it now. And it's basically that's also the reason of ROS. I mean, ROS can be executed inside a single computer, but one of the interesting features that ROS brought to robotics is the possibility to have different programs executed in different machines, and all of them attacking the same robot, the same set of sensors and actuators, but distributed along these. And that was a huge change. So now it's like the DDS is also is supporting this in the communication between the different parts.
Also, you can consider that now you have this fleet of robots and this robot swarms, that you have a system of systems of robots, and then have a very big distributed system there, and then you need something like ROS2, and you can exploit the use of a DDS there.
Okay. Great. Then what about security? So security is also a very important point in ROS2, and then which levels of security are implemented in Fast-RTPS?
Well, everything. DDS is a set of specifications, and they have what they call it the DDS security specification, and we implement all the mandatory plugins of the DDS security specification. That is authentication, encryption, and access control. And these plugins are the base of the secure ROS version. And that is why Fast-RTPS is also the default middleware for the secure ROS.
And maybe let's add again that Fast-RTPS is the only open source DDS implementation offering this premium feature.
That's right. You have some implementations out there of the DDS security specification, but just commercial. At this point, the only open source implementation for ROS2 with DDS security is Fast-RTPS.
Okay, that's super cool. I'm starting to be worried about how you are making business of this because that's a lot of stuff to be developed and very important, and you're providing this for free to the community. So, well, I don't know about your business. I'm not going to discuss here today, but I hope that you are doing a lot of business so you can keep developing all that super cool stuff. And so that's related to my next question. That is about so Fast-RTPS. You have mentioned several times that is open source, and so when you mention that is open source, then there are different types of licenses open source. So what does it mean for Fast-RTPS? Can we use it in our commercial products with ROS2?
Open source means for Fast-RTPS that the code is available for free. All users, the whole ROS community, whoever wants it, they can get it for free. There's no purchase they have to do. The license are available in our the license is for free. They don't have to purchase it. they have no expiry date, or there's no light version, there's no full version. The only version available is the free and full version, and that's what open source means.
Wow.
And also, yes, can include safely Fast-RTPS in commercial products because we use the Apache to license.
Okay.
Very open source license,
Yes.
allowing you to include your own all products in a closed source implementation. So there is no contamination, open source contamination. You can use Fast-RTPS both in open source project, but also in closed source projects without problems.
By the way, all of our products are open source. Also, our smaller version, Micro XRC DDS, is also open source, and that's the company's philosophy. It's a standard here, and we won't change it. It's not planned changing it anywhere soon or in the future, because we want to be there for the ROS community, and we also have the advantage of the input of the community, being an open source product. Yeah, because the user can contribute with helping each other and finding out bugs or commenting on them, or it's a great advantage of besides.
I see.
Yeah, it's an economical advantage for the user as well. I mean, they don't have to spend any money on it, and
Well, and you asked about the business model, right?
Yes.
Well, there are some companies, such as, for example, Red Hat, and maybe it's the best one out there using the open source model. Basically, we are a small company, and to drive the adoption, we use the open source community. Mm-hmm. So there is no barrier to adopt Fast-RTPS, because you can download the product and use the product right away. And that way, we have thousands of users. We have, at this point, more than 20,000 clones per month. That is really a lot. And some of those users are big companies that they are going to use Fast-RTPS in production, and in that case, they want support. Mm-hmm. They want support. Maybe they want an architecture study. Maybe they want a special feature just for them, and that is our model. We have a set of customers that use Fast-RTPS for very critical applications, and in that case, they have this guarantee that count on the company doing the pilot.
Okay, amazing, very cool, and I'm so happy to be able to use it, and also to create products based on that. That's amazing. And then let me switch a little bit subject, and it's about I would like to know about the relation between Fast-RTPS and micro ROS. So for the audience, let me clarify, for those who didn't listen to our previous episode about micro ROS, then micro ROS is an implementation of ROS2 for microcontrollers, and that's also another product that Proxima is developing. And so what is the relation between Fast-RTPS and micro ROS?
I think micro ROS is able to work in combination with ROS2. It helps to bring microcontrollers into the robotic environment, mm-hmm. But it's difficult to compare Fast-RTPS, which is a DDS implementation, and then something so like micro ROS has a lot more to it. So within micro ROS, there is also a DDS implementation, which is called Micro XRCE DDS, which we develop as well, also open source. And this is like the smaller brother to Fast-RTPS.
So let me clarify a little bit further there, because well, in a microcontroller, you cannot use usually DDS because you have a very low amount of resources available in terms of memory, CPU, and maybe they work in sleep, wake up cycles, and they run out batteries. So in the past, there were several initiatives to create a minimal version of DDS. And you have products out there like micro DDS and minimal implementations of RTPS to try to fulfill this requirement. But after doing these experiments, the ONG, the companies involved in the DDS standard, noticed that you need something more, because when you start to decaf a lot DDS, finally it is not DDS. So you need to create a specialized standard, and this new standard, the XRC DDS, that stands for DDS for Extreme Resource Constrained Environments, is slightly different of the DDS standard for typical computers. Okay. So MicroROS runs on top of this new extension of DDS that is for microcontrollers.
I see. So then the relation between Fast-RTPS and MicroROS is just that MicroROS uses also a DDS implementation, which is a different one than Fast-RTPS. So Fast-RTPS is a DDS implementation. MicroROS uses another one, that is the one that Catherine has mentioned, Micro XRCE DDS, and that's it. That's the relation, I would say.
Exactly.
Yes.
It's a lot different, because imagine that in the case of XRC DDS, when we are talking about extreme resource constrained environments, we are talking about 2 keys of RAM.
2 kilobytes of RAM only. Wow.
Exactly.
Yeah. Well, typical in a microcontroller. Yeah. Okay. Yeah. And then it makes no sense to load this Fast-RTPS, consuming a lot of resources. So I understand. And then, so if we don't use in MicroROS, so let's say that we are using in a Linux machine, so so we can use Fast-RTPS on a Linux machine, because it's by default is working with the ROS2 installation in Linux, so that's working. But can we make Fast-RTPS work in other platforms, or are there other platforms supported also?
Yes, definitely. You can use it in Linux, and then there are others like like Windows, Mac OS, QNX, Android, and iOS.
Oh.
Yeah. Recently, we also added, VxWorks, as we are partners with Wind River, and we just want to guarantee that the experience and the joy of the user is always there. Like they can feel free and comfortable and just use whatever platform they prefer.
Yes, you can usually, because the code of Fast-RTPS is highly portable. You can port easily Fast-RTPS to any other platforms. And for example, the port of Android and iOS are ports performed by the community. We don't support directly this in Android and iOS, but the community. And in the case of VxWorks, the work to port in Fast-RTPS to VxWorks was done by Wind River, one engineer of Yes, exactly.
Okay, nice. that just for the audience, that doesn't mean that ROS2 is running in all those systems. So we are talking just here about the Fast-RTPS framework, only about that. Okay, just clarify.
ROS2 is supported in Linux, Windows, and macOS, but
Yes.
also it's being used a lot in QNX at this point. And in the case of VxWorks, we never not only port Fast-RTPS, but the whole ROS2.
Is it?
Exactly. So
Wow.
you can use ROS2 in both QNX and VxWorks.
VxWorks.
And also you can use ROS2 on Android and iOS.
On Android also and iOS?
Yes, exactly. There was an initiative using Java and Fast-RTPS to enable ROS2 on Android and iOS, and that is available as open
Okay.
source.
Okay, I didn't know about that. Okay, interesting. Okay, so then please forget my last comment and then enjoy ROS2 in all those platforms with Fast-RTPS then. Great. So another question is that we recently have seen several reports using the iRobot DDS tests. So we saw this while at the ROSCON a couple of months ago, and they were showing a comparison between the different DDS implementations. So what can you tell us about the performance of Fast-RTPS?
Well, in the case of this presentation, we didn't know the contents until they published the study. And this case, the iRobot case, is very specific. Basically, they create a lot of nodes and a complex topology within the same application, that is, intraprocess. And in such cases, you don't even need a middleware, as I was talking before. And you have more convenient ways to share data between the different modules of your application. And, well, finally, in this corner case, they decided to create their own intraprocess mechanism for ROS2, and they incorporated that to the ROS2 communication stack. And in that case, they don't even use DDS. But anyhow, let's talk about performance in that case. Because iRobot was initially comparing very different things. They were basically started with the annual version of Fast-RTPS, the dash-in version, using Asynchronous Publishing and the loopback interface for the intraprocess communication. And they compare this with the latest Cyclone DDS released using Synchronous Publishing and an intraprocess mechanism. And of course, using that configuration, Cyclone was faster, as you can imagine. But, well, after that, after they published this study, we work with the robot team and help them to set up properly Fast-RTPS. And then, no surprises here. In that case, we are faster than Cyclone DDS, and you can check it by yourself using this a different ROS we published it to demonstrate this. And also they have iRobot published a new post in the ROS discourse with these new results. And now we perform a lot better, of course. So basically, yes, right now there is a war on benchmarking. We are working in making Fast-RTPS faster than ever, and we are betting the competition in every war we have here, not only in the iRobot case, but also in this latency and throughput test we are releasing, but also in the Apex AI benchmarking framework, and a lot of different tests that are published out there.
Oh, okay. Amazing results. And also it's very nice, very cool that you have created those ROS jets that will allow the people. So if they don't believe what you are saying, they can just go and execute by themselves and check the code if they are not happy, because everything is already there. So I will put a link to all this information that you mentioned in order to support, to back up your affirmations. That is the ROS jets for reproducing, then the iRobot post with the on this course with this new data that is showing the new results after your tuning, your help on tuning. And okay, so then we are about to finish. We have a couple more of questions, and then the one is that can you tell us examples, in real life examples, in where Fast-RTPS is being used?
Sure. We have plenty of success cases. Well, the first success case is probably Open Robotics. We have the default implementation of ROS2 and Secure ROS, and we have more than 20,000 clones per month. Mm-hmm. But also, Fast-RTPS is used in drone code. Drone code is the open source framework for consumer drones, and they use Fast-RTPS as part of the communication stack and also as the bridge to ROS2. There are several autonomous driving frameworks such as Apex.ai, but also Baidu that are using, or AutoWare that are using Fast-RTPS. We have examples of warehouse fleets of robots. So, for example, ClearPath is using Fast-RTPS, and also swarms of robots, big swarms of robots. For example, this DARPA project of Northrop Grumman that is called Offset. And outside, let's say, of the robotics ecosystem, we have many cases in air traffic control, aerospace, defense, IoT. Really many cases.
Yeah, actually, there must be thousands of cases and use cases, because as an open source DDS implementation, there's no limit, and we are not informed of all of the cases, really, because it's free. Fast RTPS is tested in so many scenarios, and then with a big community and the big guarantee of the quality. So really, the user can rely on Fast RTPS.
Exactly, because we have this such large amount of users. Fast RTPS is really tested in many ways. So it is difficult that you're going to find, let's say, an easy bug on Fast RTPS. And this is a key differentiator in other implementations out there, because other implementations, basically, they have no users. They have 4 success cases, but no users at all. And if you change or use these other open source implementations, you're exposed to this lack of testing.
Okay. So then you convinced me. So I'll buy. Then how can I start practicing with Fast-RTPS? What is your recommendation if we want to start right now?
Well, if you are using ROS2, you are already using Fast-RTPS, but if you want to use advanced features or change the default parameters, the best point to start is to read the documentation. You have a very comprehensive documentation in the docs with examples, videos, tutorials, everything. And also, you can write us, because we live on giving support to people. So, first of all, we can help you for free in your first steps with Fast-RTPS. And if you are going to production, then you can hire us to support you.
Okay. I will put a link also to your contact details for those cases that people want to contact you. So in the show notes, so they can contact. And final question then, what are the plans of the future for Fast-RTPS?
We actually have big plans. We are benefiting from constantly evolving market out there, and with a lot of more possibilities to come. And as a result, we're steadily hiring.
Exactly. So if someone wants to work here in Spain with the good temperature and weather, just write us. And specifically, we have two major features coming in the next release of Fast-RTPS. First of all, we are developing a shared memory transport to improve the performance in the inter-process scenarios, that is, same machine, different applications. And again, this premium feature will be open source as always, and no other open source DDS implementation out there offers this. We expect the first release on February. By the way, it's important to note that this development is in cooperation with Sony. They are funding us to develop this feature.
Wow, amazing. With Sony.
And a second important announcement is that for the next release, we are developing the modern DDS C++ API. This is a new standard of the ONG. Using this standard, we are going to complete the DDS API, and we are using that to change the name from Fast-RTPS to Fast-DDS.
Okay.
One thing for sure we are not going to change is the focus onto ROS2 and the community behind it.
So basically, our roadmap is driving to make ROS better in every release.
Oh, great! That's the perfect final sentence to conclude here. That's very cool, very cool. Okay, so then as Jaime mentioned, they are hiring. Oh, Catherine mentioned. Yeah, you are hiring, Catherine. Sorry, and then you are hiring. So ROS developers around the world. You see, these podcasts is also bringing you some jobs, so you can access. And they are based in Madrid, in Spain, in Madrid. Okay, so contact them. And so that's, I think that we can conclude here. We have covered a lot of topics about Fast-RTPS, and we can have now an idea of what it is, why it's so important, and how can we start using it, and contacting you in case that we need extra services or support and so on. So thank you very much, Jaime, and thank you very much, Catherine.
Thank you, Ricardo, for having us.
You're welcome. Thank you.
My pleasure, as always. And that's all for today, ROS developers. So if you like this podcast, please leave us a review on iTunes telling us what you think about the podcast and what you would like to have also in the next episodes. And also thank you very much for your 5 stars in iTunes or Stitcher. And we are finishing here. See you next week with a new lesson from the expert. And until then, keep pushing your ROS learning.